Hello friends, welcome to my channel Science Unearthed. Today we have a brand new topic that is all about bases and we will study it in detail, but don't forget to like, subscribe and share my channel. Now let us start about bases. In short, I am telling you the definition of bases. A base is any substance that in water soluble is slippery to touch. It tastes bitter if you taste it, changes the color of indicators. Indicator, red indicator is turned blue when it is dipped in a base solution, reacts with acid to form salts and promotes certain chemical reactions. Examples of bases are the hydroxides of alkali and alkaline earth metals, and the water solution of ammonia or its organic derivatives. Such substances produce hydrochloric hydroxide in water solutions. Now, first, before studying about the bases, we should know what is an indicator. Because if you are given two bottles or two containers, and these two containers they have some liquid in them, then how you will find out whether this is acid or base? So for this we have to take the help of indicators. An indicator is a dye which changes color when put into an acid or in a base. Thus, an indicator tells us about whether the substance we are testing in laboratory is an acid or base. Now, these indicators, they are of three types. First is litmus, second is methyl orange, and third one is phenolphthalein. These are the three types of indicators that we will use to find out whether a substance is an acid or a base. Now, this litmus comes in two types. One is litmus paper and other is litmus solution. It means this is available in two forms. One is litmus paper in the form of a paper and other is in the form of a solution, that is litmus solution. It is further divided into two types. One is red litmus and other is blue litmus. Two types of litmus papers are available. Red litmus paper and other one is blue litmus paper. Now, an acid turns blue litmus to red. If we dip a blue litmus paper into a solution of acid, then it will turn red. Then we will come to know that this is an acid. A base turns red litmus to blue. So if you dip a red litmus paper into a solution and it turns blue, then that is a base. Litmus is a natural indicator and it is extracted from a plant called lichen. Lichen is a plant belonging to Thalophyta. It means this is extracted from a plant. Now on the screen, you see a picture. In a container, one blue litmus paper is dipped in a solution. So it turned red. So what it shows? It shows that this is an acidic solution which turns blue litmus paper to red and other litmus paper is red. So it remained unchanged. Color does not change. Now on this picture, you see that a red litmus paper that is dipped in a solution, red litmus paper turned blue. It shows that this solution is a base. So indicator indicates whether a solution is acidic or a solution is basic. So you can find out it with the help of these litmus paper. If a drop of a given solution turns blue litmus to red, then the given solution will be acidic in nature. So this is the inference that we draw from this experiment that is done with the indicators. Example is orange juice, that orange juice turns blue litmus to red. You know that in orange there is one acid present, weak acid, and that acid is very weak, so it does not harm us when we eat oranges in our or its juice. So orange juice turns blue litmus to red, so orange juice is acidic in nature. Now other indicator is methyl orange. The natural color of methyl orange is orange. Means in its original form, this is orange in color. That's why it is named as such. It gives a red color in acidic solution. It means if you mix any acid with methyl orange, then it will turn red. It gives pink color in base solution. So if you add methyl orange to any basic solution, then it will turn pink. Now, this is the methyl orange. As we have earlier discussed, methyl orange turns red in color when it comes in contact with any acidic solution. Now, this is the same methyl orange. When it is mixed with any solution and it turned yellow, it shows that this is a basic solution. So we can find out whether a solution is acidic or basic. Now next is phenolphthalein. This is the third type of indicator. Phenolphthalein is a synthetic indicator, and this is colorless. Means in its original form this is totally colorless, having no color. When it comes in contact with acidic solution, then it remains colorless, means no color change is seen. When phenolphthalein is added to a basic solution, then it gives pink color, means it indicates that the given solution is basic or base. Now for revision purpose, I am giving you the definition of bases again. You can see it on screen. Base in chemistry is any substance that in water when it is mixed is soluble, and this is slippery to touch, taste bitter, changes the color of indicators as you have seen uh, uh, from that experiment, reacts with acid to form salts and promotes certain chemical reactions. Example of bases are the hydroxide of alkali and alkaline earth metals and the water solutions of ammonia or its organic derivatives. Such substances produce hydroxide in water solution. Now, the things that are given in this definition, we will discuss all of them in detail later on. Now, next thing is that base neutralizes acids. Means when a base is mixed with any acid, then it performs a neutralization reaction. Neutralization is a chemical reaction in which acid and a base react with an equivalent quantity of each other. Now, I will tell you in detail. Suppose a acid is mixed with a base, then the base will neutralize or destroy the effect of acid, and the same acid will neutralize or destroy the effect of base. So this is the meaning of neutralization, that the effects of both have been destroyed or neutralized by each other. So neutralization is a chemical reaction in which acid and a base react with an equivalent quantity of each other. When an acid reacts with base neutralizes the effect of acid and destroys its acidity. Means you will not find out the property of acidity in that solution because it has been destroyed or neutralized by base. Since an acid and a base neutralizes each other's effect, so the reaction between an acid and a base which forms salt and water are known as neutralization reaction. All the metal oxides and hydroxides are bases. Metal oxide. You can take the example sodium oxide, and hydroxides. You can take the example of a very simple base, that is sodium hydroxide, that is used in daily life also. So these examples are sodium oxide, sodium hydroxide, calcium oxide, and calcium hydroxide. These are the examples of bases. So have you understand the examples and the definition of neutralization reaction? Now next is, what are water soluble bases? Bases that dissolved in water are called alkalis. Means bases is general name, and the bases, a category or a group or a class of bases, those are dissolved in water. They have a special name that is known as alkalis. They have different name, alkalis. Now alkalis are soapy and bitter and have a pH greater than 7. And the pH scale measures the acidity or basicity of a compound, with 1 being the most acidic and 14 being the most basic. Now I will tell you about the pH in my next video. When an acid and a base react, they form a salt that is usually neutral. Acid and a base react, they form a salt that is usually neutral. The solubility of a substance in a solvent depends upon the composition of both the substances as well as the temperature and pressure. Means if you uh, want to dissolve a substance in a solvent, then the composition of both substances as well as the temperature, they will affect upon the solubility of substance. It means the quantity of the substance that will dissolve in that solvent, it will increase with temperature always, and pressure has also effect on the solubility. Examples are sodium hydroxide, potassium hydroxide, ammonium hydroxide, magnesium hydroxide, and calcium hydroxide. Now, there are a large number of bases. One thing is common in them. What is that thing? What do all bases have in common? When a base is dissolved in water, it always produces hydroxide ions in the solution. Means when a base is dissolved in water, then it splits in two parts or two ions, and one ion will be hydroxide ion or OH. So when you dissolve sodium hydroxide in water, then it produces hydroxide ions, that is OH minus. These are hydroxide ions. Now chemical equation is NaOH plus H2O equal to Na and OH. means when it dissolved in water, then it splits into two parts or divided into two parts, Na plus and OH minus. OH minus is the hydroxide ion. Other example is potassium hydroxide, KOH. It is found in solid state. So when it is dissolved in water, then it also dissociates. One part is K plus, that is potassium ion, and other part is OH minus, that is the same hydroxide ion that was produced in previous equation or reaction. So in these two reactions, you see one thing in common, that is OH minus in both the equations. It means when any base is dissolved in water, then it will give you OH ions. So this thing is common in all the bases. Now, all the bases, they are classified or divided into two groups. First is strong bases and second one is weak bases. Strong bases Strong bases are substances that can completely dissociate in aqueous solution to produce hydroxide ions. As I have told you earlier, that when a base is dissolved in water, so it is divided into two parts or it is dissociated into two parts. First part is metal ion and other part is OH. OH is hydroxide ions. So in the case of strong bases, if you add, suppose we can take one example to understand it. You take 5 molecules of sodium hydroxide, 5, and you are dissolving these 5 sodium hydroxide ions in sodium hydroxide molecules in water, then all the 5 molecules, they are dissociated or dissolved in solution. It means the base is completely dissociated in the aqueous solution. So this is the example to show that strong bases are substances that can completely dissociate in aqueous solutions to produce hydroxide ions and cations. They are often formed from the hydroxides of alkaline earth metals and alkali metals. So these are the strong bases. When you put them in water, then they are completely dissociated or divided into two parts or two ions. Some examples of strong bases, they include potassium hydroxide, sodium hydroxide, barium hydroxide, cesium hydroxide, strontium hydroxide, calcium hydroxide, lithium hydroxide, rubidium hydroxide. Now, there are certain properties of strong bases. First is they deprotonate weak acids. First, I will tell you the meaning of deprotonate. D means to remove. Anything, if I remove from a substance, then this is known as deprotonate. Deprotonate means if you remove proton from any chemical substance, the process is known as deprotonate. So strong bases, they deprotonate weak acids. Now you have understood the meaning of deprotonate. Deprotonate means to remove proton. It means the strong bases, they remove proton from weak acids. If they are mixed with weak acids, it means they will get or they will take the proton from the weak acid. Or in other words, you can say that they deprotonate weak acids. Now, second number is deprotonate very weakly acidic CH groups in the absence of water. If we add to some chemical substance, but we do not add water, then they deprotonate very weakly. Means they will not deprotonate all the molecules. Number 3 is neutralizing acid spills with strong bases can cause a violent exothermic reaction. If you add acid spills with strong bases, then it causes a violent exothermic reaction. Exothermic reaction means the reaction in which heat is generated. Exo means to come out or exit. Thermic means heat. So the reaction in which heat produced, that is called as exothermic reaction. So the mixing of acid pills with strong bases will generate a large amount of heat. Weak bases like baking soda or egg white are safer to use for neutralizing acid pills because they will not produce such a big amount of heat. So they are safe. Next one is weak bases. Other category or the other group of bases is called as weak bases. A base which is partially ionized in water and thus produces a small amount of hydroxide ions is called as a weak base. It means if you add a base to water and this is not fully ionized and this is if it is partially ionized, then that will be a weak base. A weak base is a base that upon dilution with water does not dissociate completely, so that the resulting aqueous solution contains only a small proportion of hydroxide ions. So this is natural. When all the molecules they are not dissociated, some molecules remained undissociated, then naturally you will find out only a small number of hydroxide ions. So they will give a small number of uh, hydroxide ions and the rest of the proportion will remain undissociated. Examples are aluminum hydroxide, other is lead hydroxide, third one is ferric hydroxide, copper hydroxide, zinc hydroxide, trimethylamine, methylamine, nitrous oxide. All these are the examples of weak bases. Now we have come to the other thing, that is properties of bases. Bases are bitter in taste. Bases feel soapy to touch. If you take the solution of some base and you rub it with the tip of your fingers, then you will feel soapy, just like soap. So they feel soapy to touch. Example is sodium hydroxide. Bases turns red litmus to blue. Bases conduct electricity in solution. If you pass electricity in a solution of a base, then the electricity is conducted through the solution. Bases react with some metals to form hydrogen. As for example, the example you can see on the screen, zinc reacts with sodium hydroxide, so it forms hydrogen gas. Hydrogen gas is evolved. Bases react with acids to form salt and water. Sodium hydroxide is base, H2SO4 is an acid. So when both react, they give Na2SO4, that is a salt, and H2O is water. Bases react with non-metal oxides to form salt and water. Non-metal oxides, calcium hydroxide. Calcium hydroxide is a base. CO2. CO2 non-metal oxide. Carbon is non-metal, you know. So its oxide will be non-metal oxide. So when calcium hydroxide reacts with CO2, then it gives calcium carbonate CaCO3 and H2O, water. Metal oxide ये हो गई CaCO3 and H2O, that is water. Then uses of base. All of them, they are used in our daily life also. Sodium hydroxide is used in the manufacture of soap, paper, and synthetic fiber rayon. So all these are the uses that we use in our daily life. Calcium hydroxide is used in the manufacture of bleaching powder. Magnesium hydroxide is used as an antacid to neutralize excess acid in stomach. When excess acid is produced in stomach due to some overeating, then excess acid is produced in the stomach. You know that hydrochloric acid is produced in the stomach. It helps in the digestion, but when it is produced in excess, then it creates problem. So to neutralize this acid, we use magnesium hydroxide, that is uh, that is found in a form of a medicine, that is milk of magnesia. Sodium carbonate is used as washing soda and is softening of hard water. Sodium hydrogen carbonate is used as baking soda in cooking food and as an antacid to cure indigestion. Now, there are some theories. Theories means some details that are given by some scientists regarding bases. One scientist is Bronsted and Lowry theory. Bronsted and Lowry theory tells us that a simple definition of base. He said an acid is a substance that is capable of donating H plus ions, and base are those substances capable of accepting hydrogen ions. It this thing I had told you earlier. Deprotonation. Deprotonation means a base takes out protons from an acid. This is deprotonation. And the same thing is given in other words by Bronsted and Lowry. He said an acid is a substance that is capable of donating proton, H plus ions, and base are those substances capable of accepting H plus ions. In short, bases are proton acceptors. And on other hand, if we say these acids, they are proton donator. They donate proton. They are donor. Examples are, take example of the ionization of hydrochloric acid in water. When hydrochloric acid is mixed in water, then H3O is produced. H3O. H2O, what is an H2O? It plays the part of a base. So it takes one proton from HCl and it turns into H3O. After taking one proton, it forms H3O, and on the other hand, this acid, HCl acid, it lost one proton, so it turned into Cl, chloride ion. So this is the example of deprotonation, we can say. Uh, so this is all about bases. Now don't forget to like, subscribe and share my video. Thank you very much.